Okay guys, trying this out. It's the first time I've done this, so I've got my notes up here so we can kind of go through them first and then for me to write down the new examples. Don't make fun of me. This is very weird. So, okay, first off, 9.1 is just basically about right triangles. So first you have to solve all the triangles. So if you look on the screen, basically they will give you some combination of side lengths and angles, and you have to find the rest of them. So example 1 and 2, I did that for you. You're going to be using your calculator a lot, and I put in stars up here, make sure it's in degree mode. So to find first, and I know they're out of order because when I wrote it wrong, but first you have to find angle B. You have to use tangent because you know the two side lengths. So in your calculator, you use inverse. Plugging in is 27/14. That's opposite over adjacent. And they'll give you angle B. And it says round to 2 decimal places, so 62.59. Then once you have angle B, you can find angle A by just subtracting it from 90 degrees because all 3 angles have to add up to be 180. And this is a right triangle. So then you can find angle A. Once you have your 2 angles, you could go in and use Pythagorean theorem to find your third side length. So it kind of just depends on what they give you. Like example 2, they gave you 1 angle and only 1 side length. So first thing, you find your other angle by doing 90 minus 39, you get 51. Then you can use tangent, or you could use sine if you wanted to find C first. I just found the order of these two doesn't matter. So tangent of 39 would be 8 over B. So if you did your algebra, basically the B and the tangent switch spots. So in your calculator, this is what you would put in. 8 divided by tangent of 39, that's not the inverse, that's regular tangent. It'll give you the side length of B. Because you rounded this, you don't want to use Pythagorean theorem to find the hypotenuse. I mean, you can probably be about the same, but the easiest way to do it would just be sine of 8 over C because C is the hypotenuse. So then basically 8 divided by sine of 39, 12.71. So these are questions, I sent it to you on a little screenshot in Snapchat, like 1 through 4 or something. You're just solving triangles, finding everything. So those are pretty easy. Then it basically is the same type of stuff, except it gives you in word problems. So this is just another example, but in word problem form. I think you have to figure that out. Most of you have already. Okay, angles of elevation and depression. So angle of elevation is when you're looking up from your line of sight. So you would draw your triangle that way. Angle of depression is when you're looking down. So usually you would draw your triangle here and here. Whatever the angle of depression is here, it's going to be the same right here in your triangle. So your angle of depression is not this angle at the top. Y'all see where my mouse is moving? But it's right here. And I can show y'all that on the on here. Give me a second to make this the big screen. Okay, so if you have an angle of depression, so say it was like a plane up here, and it was like looking down at something over here. This angle is your angle of depression right there. But when you draw a triangle, a right triangle so that you can solve it, this angle up here is the same as this one down here. So this is your angle of depression. So that's a little bit different when you're using depression. Elevation is just when you're looking up. So like if there was a person looking at like, I don't know, a kite or something up here, this is your angle of elevation. So depression is the one that's a little bit trickier. Elevation is easy, but y'all should have done that in geometry probably. Okay, let me go back to screen share just a second. Okay, so I did an example of that for you. Hang on just a minute. Okay. So a hawk could do spots mouse. So this one is an example of depression. See, it was 19 up here in the corner, so it's 19 down here as well. And then you can just round it. Make sure you read the directions because it'll tell you how to round, and it could be different on each problem. Okay, now example 2. These are the hard ones that I said I would do with you because this is when you kind of have to use tangent twice. So, but it's here in your notes if you can kind of understand it. If not, I just kind of wanted to talk y'all through it. So it says determine the diameter of this circular entrance. So in the problem, it talks about like a cave or something, and you'll see the picture. But it wants to know just what this height is, basically, of this circle right here. So you have two triangles. You have this smaller triangle, and you have this big triangle. If you can find the heights of both of them, then you can just subtract. So I labeled it pretty well for you, x1 and x2. So you find the side length of that first little one by using the little angle, the 38.5 angle right here. So tangent is opposite over adjacent. So x1 over 250. This one you just multiply 250 to solve for x. And you got your x1 is 198.86. The second one, you're going to use the bigger angle, 43. And you're going to do 250 because they have that same side length at the bottom. But it's x2, and this time it's tangent of 43. So you get 233. And then you just subtract 233 minus 198 is 34.27. So that's that one. I think you guys can get it. If you have any questions with these, just screenshot it and send it to me. You can send Snapchat. I don't really know how to work Snapchat that well. Like I never can figure out how to get off the picture. I could probably respond better and remind. You could just do it me and you versus in the group chat. But either way, I'll try to keep up with both. So any questions on those? That's just 10 and 11. It's just two problems that'll be a little bit hard. Let me know. Okay. Then when we go into law of sines, okay, this is new. You might have done this I think I did it with my advanced math class, but basically law of sines have the same ratios. So little letters are side lengths, big letters are angles. So A, which would be the side length across from angle A, and B, which would be the side length across. They should all make the same ratio. So you could do it with the angles at the bottom or the angles at the top. I generally use the angles at the top of this one. Okay, so now the first few questions, 1 through 6, are deciding if you can use law of sines or not. You can use law of sines if it's one of these 4 options. So if they give you side angle angle, so it would have to look like this, and it can be flipped anyway, but side angle angle, and notice that this side is across from this angle. One of them has to be across from each other. If not, then you can't use it. Okay, you could do angle side angle, where the side is in between the 2 angles, because you could find this third angle easily. Okay, you could do side side angle. Again, one of the sides has to be across from one of the angles. Side angle side. Side side side. And angle angle angle. So any of those cases, there will be some where you can't. So just kind of use this chart to help you figure those out. I'm sorry, I'm just reading this. Okay, law of sines can't be used for everything on this chart. For sure, this one, and this one is fine. But for these, you have to know a sine, but the last three you cannot use law of sines for. That's what this first little section is doing right here. Okay, so only for side angle, 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 side angle, and side angle. You have to know an angle and the side length across from it to be able to use law of sines. Okay, so here is, you just use it to solve. So they basically gave me a triangle. I know two angles and I know the side opposite of B. So because I know all of B's, you can set up that proportion. Sine of 48 over 8 is equal to sine of 63. We don't know A, but we can find it. And you just cross multiply using proportions. So 8 times sine of 63 and A times sine of 48. That's what I had here. Trying to get A by itself, so I divide by sine of 48. So you just plug all of this in your calculator. I would use parentheses around the whole numerator part. So parentheses 8 times sine of 63, parentheses divided by sine of 48 equals 9.6. Okay, then you do the same thing, but with C. It's really easy to find angle C because all the angles in the triangle have to add to be 180. So 180 minus 63 minus 48 is 69. I would use what they gave you, not what you found, because if you did this wrong, then this answer is going to come out wrong again. So again, use sine of 48 divided by 8 equals 69 over C. Cross multiply, divide, and we got C is equal to 10.1. So those are pretty easy as well. Sometimes they'll give you a picture, sometimes they won't. They'll just give you this. And that's why I gave you that one, because it's a little bit harder. Pictures are easier to see. Okay. This is the harder part on section 9.3. So it's, you have to decide if you have no triangle, one triangle, or one or two. So basically you need to find out what sine of B is. Okay, so if sine of B is greater than 1, that means your angle is too big for your side lengths to reach, so it's no triangle. If side length of B equals, sine of B equals 1, then you got a right triangle. B is a 90-degree angle. And if sine of B is in between 0 and 1, so it has to be positive, but it's less than 1, then you could have 1 or 2, and I'm going to show you how to figure out if it's 1 or 2. Okay, so I think I did kind of an example of each of them. So this one gave us two side lengths, A and B, and then it gave us angle A. So you have to find sine of B first. It's going to be the first part A. So you just do it. Sine of B over 16.3 is equal to sine of 56 over 15, because that's sine of A over little a. Okay. We're solving for sine of B here. So I had to get rid of 16.3. So we're going to put all this in your calculator. And when you do that, I would do sine of 56 divided by 15 times 16.3. And in my calculator, I got 0.9. So it's in between 0 and 1. So I have 1 or 2. And then I think they make you plug in both. Like this is a part, that's why I put a box around it, part A. And this is part B. That'll ask you no, 1, or 1 or 2. So you can put 1 or 2. Then they're going to ask you, well, what is B? So back up here at sine B, and I wish I could like write on this. That would be helpful. Let me see. I guess not. So you would just plug it in the calculator, and I don't know if this is too little for y'all to see over here, but basically you would put in sine inverse of 0.9009. And it'll tell you it's 64.3 degrees. So that's just the inverse. So you get B1, then you can go ahead and find C1 after that using the law of sines. Okay, to figure out if you have a B2, you're always going to do 180 minus B1. Okay, so always, always, always 180 minus B1. And it is 115.7. So what you have to do to figure out if B1 works is you have to see if you can take B2 plus A. And if it's less than 180, then it works. If it's bigger than 180, then it doesn't work and you just have one triangle. I hope this makes sense. It's hard because I can't have any feedback. But maybe I'll write that down over here so you guys can see it. Hang on just a second. Okay, so hang on. Okay, so that you can see this better. Okay, so right now we have our B1 is 64.3 degrees. But on the same part, I think this will be part C. You'll either have an option for B where you can just plug in B1, where you can plug in B1 and B2, or it'll have an option of no triangle. Okay, so to find B2, you do 180 minus B1, always. So in this case, it's 180 minus 64.3, which equals 115.7 degrees. Okay, so we found it, but you have to check to see if you can use it. So to check, you take B2 plus A. If it's less than 180 degrees, you can use it. If it's bigger than 180 degrees, you cannot use it. You just have one triangle. And so then you would just, so if it's greater than 180, you would just use the B1 option. But if it's less, then you would use the B1 and B2 option. So B1 is still 64.3, but then you would also have to plug in your B2 as 15.7. So for ours, we have 115.7 plus A was 56. That is, and I'm doing the math in my head, 171.7, something like that. So it is less than 180. So ours work. So we would plug in B1 is this, B2 is this. Then the next part would be D, and they're going to ask you for angles C1 and C2 because we're telling them we have two triangles. So for C1, you do 180 minus A minus B1. For C2, you do 180 minus A minus B2. So here, that's 180 minus 56 minus 64.3. And we got C1 is equal to 59.7 degrees. Over here, we got 180 minus 56 minus 115.7. And we got C2 is 8.3. So that's a very small. Okay, and then finally, the last part would be to find side lengths. So little c. Sorry, my son just walked in. Go see daddy. Go see daddy. Thank you. Okay, so to find those, you would just use your laws formula. So we know A, and I would use A because that's what they gave us in the original problem, but you would use sine of 56 over 15 is equal to sine of 59.7 over C1. For this one, same thing. Sine of 56 over 15 is equal to sine of 8.3 divided by C2. And that's how you would find them. So I think y'all already know how to do this. So I'll just go ahead and give you the answers. You get 15.6 here and 2.6 here. So then that would be the last part. And you'll just have several problems like that. And then if you look back in your notes, the last part is just showing you the 3 cases where law of signs can be used. And then objective 4 says using law of signs to solve applied problems involving oblique triangles. It's probably just going to be like word problems, but it's the same kind of stuff over. So again, section 9.2 is 29 questions. Section 9.1 has 16 questions, and I sent y'all the breakdown of those. These are going to be due Thursday night, both of them. So don't wait till Thursday to do both. Most of y'all have done 9.1, so that's great. These will be due Thursday night, and we're just going to stay on this schedule. Monday, I'll send out a video of me explaining like this. Thursday night, the homeworks will be due. Friday night, no, I didn't want to do it on Friday night. So then Sunday night, you'll have the weekend to do the quiz. Okay, and I have a little schedule. This is kind of the schedule. I'll slip it under here in case you didn't get it. But this is where we are this week. So this is going to be due Thursday, quiz 10 Sunday, which will be on these 2. Next week is 9.3, 9.4. And then after that, it's just 1 homework and 1 quiz. But these are bigger. These are like 60-something questions on these. So I'll make those 30 points. Hopefully, we will be back in school on the 20th. And so I might move homework 10.4 back. But if you want to get it finished, so like when we come back, you can just focus on tests. This won't be, you won't have any quiz on this. This, I don't even think they put, this is vectors. I don't even think you have any vectors questions on your final. It's just a little extra homework. But we could, we have to have this homework done before we take the final. So I know test 3 is hard. I would try not to forget this stuff though, like, because we're moving into totally different things in chapter 9, chapter 10. So keep like going back, taking practice tests, practice what you missed on practice tests, just to keep it kind of fresh in your mind. Don't forget about that. We will do it when we come back. I'll do it with you, but we've got to take test 3, test 4, and the final all before like May 5th or something. So that literally gives us 2 weeks to get all that done, and y'all need 2 days to do each test. So test 4 is a little bit easier, but then the final, you want to have time to read for that because it's cumulative. It's all the tests. So let me know. Again, keep in contact with me when y'all have questions. Remind probably is the best. This app that I'm using to make this video is actually a conference call video. So if you want to, just email me, Remind, say it on Snapchat. We could actually set up a time to where like y'all could get on your phones and call in and ask me questions while I'm explaining, which might be a little bit more helpful. So if you want to do that, let me know. We can figure out a time that works best for everyone. So good luck, guys. Hope you're staying well, staying safe. I miss you. I hate that we even have to do it this way, but it's just what we have to do right now. Let's try to make the best of it. Let me know if you have any questions. See you next time.